Hello, hey, this is John Ratzlaff. This is for FTT 122. Today, I want to go over understanding of explosives, propellants, and primer designs. Firearms ammunition relies on precise chemical reactions to function effectively. Understanding the difference between explosives, propellants, as well as considering advancements in propellant technology is crucial for firearm enthusiasts and professionals. Let's go over the difference between an explosive and propellant. So while both explosives and propellants involve rapid chemical reaction, they differ in how the energy is released. Explosives is a substance that undergoes a sudden, violent release of energy, creating a shock wave. This reaction is nearly instantaneous and is typically used in demolition, mining, military applications. Example is TNT and like C4. So a propellant, more or less what we're focusing on, is a substance that burns in a controlled manner to generate expanding gases, which creates pressure. In firearms, this controlled burn pushes a projectile down the barrel and causes an explosion. Smokeless powder, black powder are all common just uses for this type of propellant. The key distinction is that propellant produces controlled energy release, while an explosive produces an uncontrolled rapid detonation. Should the firearm industry move away from traditional propellants? Well, the use of traditional smokeless powder as a firearm propellant has remained largely unchanged over a century. While effective, there are potential reasons to explore alternatives. Environmental concerns. So, modern propellant contains chemicals that contribute to pollution and can be harmful to soils and wastewater. Residue and maintenance. Some propellants leave behind carbon buildup, requiring frequent firearm cleaning to maintain reliability. And then storage, stability, sensitivity. So traditional powders can degenerate over time and become unstable in extreme conditions. Alternative propellants. So kind of like we talked about before, it might not be exactly usable in, like, let's say, maybe handguns right now or small arms, but a railgun system with electromagnetic acceleration is a possibility. Liquid propellants as well. Research has explored liquid propellant-based fuels that can allow for more precise burn control and reduce residue. Caseless ammunition, a self-contained propellant and projectile design, which could reduce waste and weight. Though reliability challenges are still remaining, even though that's still something that's being created at the moment. While these alternatives present exciting possibilities and endless options, hopefully here in the future, traditional smokeless powder still remains the dominant choice just due to its proven reliability, cost effectiveness, and ease of manufacturing. So there's 3 primer designs and the functionalities, and I want to go over that with you here. So the first one I have here is going to be the battery cut primer. So this primer consists of an anvil and a separate priming compound held in a metal cup. And I did demonstrate that here for you guys here. So this is going to be your priming compound in blue. This is going to be your priming cup here that's outlined in red. And then your anvil, which dips down by the priming compound. And then this is just going to be your battery cup itself. So, and then this one does have a single flash hole. So this one is going to be your shotgun shell primer. And reality, the biggest thing with this is it's just most effective in shotgun applications. So after this one's done, this is going to be your battery cup. We're going to go on to your boxer primer. So your boxer primer here is fairly simple. I do want to go over just a few things with you. So this one's going to be more commonly found in all of our centerfire rifle cartridges. The primer uses the single flash hole, and then it has a built-in and built-up anvil, as you can see here in the green. And then we still have our cup, which is in the red, and then the blue is our primer compound. But the big key difference in this one versus the next one I'm going to go over with you is that it does have a single flash hole, and the inside of the cup actually has the anvil. So that's going to be our boxer primer cartridge. The biggest thing with it, though, with that boxer is that The main advantage of it is that they allow for ease of reloading, as spent primers can be just easily removed and replaced. The Berdan, a little bit different, and this is going to be found in your surplus ammunition or your European ammunition. The design has 2 flash holes, and it doesn't have a built-in to that primer cup, but it's actually itself within the case. So as you can see the anvil here, we do have the primer cup in red, like we talked about before, and then this primer compound. The big key difference too, though, besides the anvil itself being not integrated down here, is it's actually going to have the 2 flash holes. So while this is less expensive to manufacture, Berdan primer cases are difficult to reload due to their complexity of removal. Just something kind of key here, just to let you guys know. I want to go over just a few things here for you. So the purpose of the different primer designs, we're going to have boxer primers are favored for civilian commercial use due to the reloading capability. Berdan primers are commonly used in military application just due to their cost effectiveness and their durability. And then the battery cut primer provides reliable ignition source for shotguns where different pressure requirements exist. Understanding the differences between explosives, propellants, helps in grasping firearm functionality, while alternative propellant sources could offer improvements in environmental impact and firearm maintenance. Smokeless powder remains the industry standard today due to this reliability. Finally, primer designs play a crucial role in ignition, with boxer primers standing out as the most reload-friendly option. Thanks much. Have a good one.